Good evening, ladies and gentlemen. We are glad to see so many enthusiastic participants joining our webinar today. I'm Nimashi Fernando, the Seminar Secretary of the Sri Lanka Energy Managers Association, and I warmly welcome you to our 69th Energy Management Forum titled Potential in Waste to Energy, the Practical Approaches. This EMF will be conducted by Dr. Engineer Arosha Hemali, lecturer at the Faculty of Technology, University of Sri Jayawardenepura. Dr. Arosha has obtained her engineering degree in chemical and process engineering from the University of Moratuwa and has a PhD in circular economy in material and energy symbiosis modeling from the University of Moratuwa in collaboration with the Deakin University of Australia. She is a visiting lecturer at other key universities in Sri Lanka, offering her expertise in environmental, safety, and sustainable development fields. She is also a chartered environmentalist and national energy expert and the trainer under the UNIDO Industrial Decarbonization Initiatives, national expert on EU Switch Asia Policy Support Component on application of circular economy and sustainable production and consumption across national NDC processes, and a technical consultant at Innova Environmental Services. Dr. Arosha has over 18 years of experience in manufacturing industry, in environmental engineering, energy management, and business development fields. So without further ado, I take pleasure in inviting Dr. Arosha Hemali to conduct her presentation. And audience, if you have any questions, you can direct them to the Q&A chat box, or you could also raise your hand during the Q&A session. Thank you. Dr. Hemali, the floor is on to you, madam.
Okay, thank you, Nimashi, for the lengthy introduction of mine. And I'm happy to share my experience with you today, especially on the waste to energy perspective and the potential energy and the practical approaches through waste converting into the resource field. So let's move on to how this, I'm just giving some sort of insight how this waste is creating. So, we call this as economical misbehavior, meaning we use raw material as well as energy for all our economic activities and produce product and basically the product also and the services as well as the useful outcome. And then similarly, waste, the portion of these energy and the raw material would convert into the waste material as well. Waste in the sense we are considering on the mainly the solid waste and the liquid waste, etc. Right? Not the other forms of waste. We are not talking about, for example, time waste, etc. Right? So, in order to produce this waste, we use raw material and energy, which are finite resources in the global environment, right? So if we can convert this waste into resources and get those back into the economic activities, then obviously we will save precious raw material as well as the energy that is coming from the conventional energy sources. So that is where our today's topic, mainly about how we convert this waste into resources, thereby generate energy. So let's move on to the topic. In the sustainable waste management approaches, we are basically practicing a sort of waste management hierarchy, meaning how we effectively manage waste. Obviously, we all know if we can avoid the waste, that is the best option, meaning then it comes with all the sustainable production and consumption methodologies, etc., right? And then minimization. If we can minimize the waste, that then again it will save that the initial raw material as well as the energy that we are using from the earth to produce new material, right? Both avoidance, minimization would support for that. And then it comes to the recovery or the reuse or the recovery of the material. So that comes to next. And then if we cannot recover the material that is inside the waste, we call that whether we consider that whether we could convert the energy out of these material, the energy which is embedded in this material into the valuable sources. We call it as waste to energy conversion or co-processing. I will discuss all this technique with you all. So the techniques up to now, we call it as recovery techniques, of which some techniques we actually can recover the material, and if we couldn't recover the material, then the energy recovery, right? So those are the two main objectives in our, the sustainable circular economy concepts. So in order to manage the waste, there are some other techniques as well. We all know that incineration, chemical treatments, landfilling, unmanaged waste dumping, and everything, right? So somehow our communities and the municipalities, they are managing the waste via these either these recovery techniques or the disposal techniques. We know that we are in the economics and the situation that the resources are depleting, and we are working in a very finite resources as a global. So we need to think ways and means of recover the material as well as recover the energy. So that is where we need to push all these technologies towards the recovery techniques rather than purely disposal of the waste, in order to avoid from the waste problem, right? So in global context, I took from some data of the World Bank, and this is the basic composition of the waste. See, if you can see, the organic waste is coming into the high portion, where almost, this is regarding the global waste context. The region to region, country to countries, there'll be changes and the variations. But however, we know that the food waste or the biodegradable waste comprises of majority of the portion. And then it comes to the paper, cardboard, plastic, the glass, metal, etc. Right? So keep that in mind. In Sri Lankan context, actually, Western province itself comprises of nearly 60% of the waste generation because of the high density of the population and all that. You can see these types of waste dump yards and open dumping, burning, all sorts of mismanagement of waste in our country as well. This is not only Sri Lanka, most of the developing countries, this is the situation. Especially in the Western province, we actually have 25 this kind of waste dump yards, right? So just think, most of this material contains high energy content, right? Luckily, now we have the waste to energy plant, at least one waste to energy plant to recover the energy out of this. But actually, we need to consider the recovery of the material of this as well. Then you will save the raw material as well as the energy. If you recover the material out of these waste, you will recover both raw material as well as the energy that is used to produce this material as well, right? So today we discuss about the different techniques of waste to energy. Waste considered as a resource to produce energy, right? Of which we'll discuss about the waste to energy from refuse derived fuel and the co-processing, industrial pyrolysis, biogas generation from the waste, and landfill gases conversion into the electricity, and even biochar production, also one of the upcoming, trending technologies, right? So there are several ways to treat waste. This term MSW refers to the municipal solid waste because most of the household waste coming into the municipal solid waste channels, right? So if you consider the MSW, so there are, as I show you, different ways and means of managing waste. So there are good ways of managing waste as well as just to manage. For example, open dumping is just to manage waste, but it's not at all a good method of managing. So if we consider municipal solid waste, there are a lot of, good portion of this municipal solid waste would have these material would have the high calorific value. Then it's very potential to have the waste to energy process and get the energy, recover the energy out of this material, as well as co-processing. Those two techniques are, I would say, large scale, which you can, experience. And even in our country also, we have these technologies that are using and utilizing these material to convert into the energy sources, right? I mean, if you are want to produce waste to energy, you need to convert this waste material into we call it as pre-processing mechanism, into refuse derived fuel. We call it as refuse derived fuel, right? So if you consider this recycling also, I would say that also would support to save energy a lot. Because if you can recycle these materials, then in one hand, you will save the energy consumption for producing new virgin materials, as well as you will save the materials, the raw materials that is need to produce these materials from the stretch, right? So recycling also one of the best technique to save energy. And then we consider about the waste management technologies. We can categorize into two areas: thermal treatments as well as biological treatment. So when it's come to in the thermal treatments, all these combustion, gasification, pyrolysis, etc., that are coming under that category of waste management techniques, which are converting these material into the energy sources. And biological treatments is basically biochemical reactions. You produce bioethanol, methane, with the digestion, etc. So there are basically, especially for the biological waste, in the sense biodegradable waste, as I shown you, the majority of the portion of the municipal solid waste would comprises of the biodegradable waste. So these techniques also would support to convert these waste material into the energy sources. So waste treatment methods that are available in Sri Lanka, obviously the recovery, the recycling, resource recovery plants are available, and as well as waste to energy. Luckily, we do have one plant in Colombo. So through this, there are massive amount of waste is being converted into energy. So there are some positives, negatives as well, because still they are having some issues on the fly ash, how to dispose the residual out of their plant. Still, they are having this issue. Not actually the fly ash, the bottom ash, the latter part of the residue. And then it comes to this co-processing through cement plant, one of the best technology in the global, in order to, securely manage the hazardous waste as well. In our country, Sri Lanka, also, we are practicing this in, I would say, hazardous waste in massive context, and it's very proven technology across the globe. This is, I mean, I do have the personal experience of most of these plants. So this particular plant in the latter, actually, I was there during the commissioning as well. So then it actually convert the rubber and the hard plastic material into the valuable products. We'll be discussing those in the latter part of the discussion. And when it's come to the waste to energy, so there are what really happened inside it is, I'm quickly just going through the how it happens and so on and so forth, right? So you will feed the waste into this combustion chamber. Obviously, it would be the controlled environment. And then when the waste is having a sort of calorific value, that material would get burned, and that gives the fuel to the process, and it itself would produce the heat, and that will support to generate the steam and then the turbine and the electricity generation. That is a basic process, right? However, this generate bottom ash as well as fly ash as residue. In this technique, you need to have a proper disposal mechanism for this bottom ash as well as fly ash. right? So, however, this will be really supporting to manage waste and convert the energy of the waste into the valuable resources to generate electricity. And the co-processing. This is, we call it as, there are two processes happening simultaneously where this co-processing is actually with the cement kiln co-processing, cement manufacturing process, as well as the waste disposal, and whatever the energy, if it is contained in the waste, would convert into the thermal energy during this process, right? So here, inside this reactor, it's fully enclosed. It maintains 1800 to 2000 centigrade of temperature, where then again, these waste material would convert into its atomic form, meaning carbon, hydrogen, nitrogen. However, if there's any heavy metal content in the waste, there are certain waste, small amount of heavy metals contained, that actually not going into the gaseous phase, that will be retained in the material. But since this process is fully monitored, the 24-hour monitoring, and the before feeding the waste into this system, it's fully monitored the content of the waste chemistry. So then with the limits, this process can be happen, right? So, and this temperature is like 1/3 of sun's surface temperature. So due to this temperature, this material conversion, the material converting to atomic form, right? So that is a technology that is using for hazardous waste management, proven technology in the global, right? So here the good points are there's no any such like fly ash or bottom ash residues retaining in the process, right? So because it's due to this high temperature, all these material composition, meaning the material is converting to the atomic form. So it goes with the gaseous phase, whatever the carbon, hydrogen, nitrogen, it goes as SOxes, NOxes, and carbonates, etc. But it's fully monitored and controlled environment. The emissions are fully monitored with the limits. There's the provision to emit to the environment. So this is proven technology. Anyway, if the cement manufacturing is happen, these emissions are there. So there's no any additional emissions because of the waste disposal like this. Right? That is why I would say this is a proven technology in global. And then about the industrial waste tire pyrolysis. So here, the tire pyrolysis actually involves in the certain low temperatures, but absence of oxygen. So during this pyrolysis, these tires, meaning tires generally have the long carbon chains inside its structure, right? It breaks down into the smaller molecules, and then these products, as the output, it convert into the liquid phase, where we call it as pyrolysis oil. If we can purify it, it's actually can be an alternative for heavy furnace oil because it has very high calorific value. And then carbon black, it's having a calorific value very similar to coal, the high quality coal. Actually, you can substitute coal with the carbon black, these particles, as the solid fuel, and the pyrolysis oil is the liquid fuel. And pyrolysis gas, it's actually the once we convert this material into the absence of oxygen, this will convert into the gaseous phase as well, right? So this gas you can actually use as the fuel for this process as well, right? So this is very nice process. Actually, I have seen and I have experienced. In most of the other countries, they are using this as a commercial, the fuel production out of tires, right? So there are various, number of plants set up, and they will get the oil as the energy output, and the carbon black as the solid output. Again, it can be used as a fuel. And then the gaseous phase, we call it as pyrolysis gas or the syngas, right? So it's the very proven technology to dispose, rather manage tire and the hard plastics waste. So this is again the description of it, right? Industry. This is an industry that convert waste tires into pyrolysis product like pyrolysis oil, gas, and carbon black. So these plants, actually in Sri Lanka, we have a couple of plants commercially available. They sell the products to the industries. So happy to say, actually, they are managing quite well. But the other countries, they are having massive industries. They develop the industries with pyrolysis technology. And then I will move on to the municipal solid waste. I mean, the techniques actually so far I discussed both mix waste to energy plants. Of course, you can use for the industrial waste as well as the municipal solid waste as well, the cement kiln co-processing. Pyrolysis plants, also the tire products, tire waste you can use, particularly onto the municipal solid waste, especially in the low-income countries. And the nature of this low-income countries, in the sense, mainly comprises of the low-income countries. Plus, if it is in Southeast Asian region, the moisture content of these waste is quite high. So the biological treatment would support for this as well. Unlike, I mean, in Sri Lanka, we are having only the composting methods for the biodegradable waste, but the other countries actually they have different technologies to convert into the municipal solid waste into the usable energy forms, right? So actually the drying methods also would support to convert this material into the pre-processed material. Then it converts into the valuable product. So this is one of the example. We call this method as bio-drying, where this example is actually not available in Sri Lanka, but most of the other countries, they use these kind of techniques. So they take this kind of material and it act as a membrane, right? So your biodegradable material is there and you have laid this membrane, and the biological reaction of the biodegradable waste would happen inside this, right? Then it actually get heated up, and then it convert in this material into the again the kind of refuse derived fuel, which this material would contain the high calorific value, again suitable for the combustion, right? Again, convert this material into the thermal energy sources, right? These are some of the examples of Southeast Asian countries and even the European countries. They are having the massive plants of this technique, especially for the biodegradable waste. So there are these kind of situations as well in the other countries, right? This is one of the plants. And so even European countries, actually, they use these techniques not only for the biodegradable waste, but also for the mixed waste as well, right? So once this mixed waste is dried, and then it will get the high calorific value, right? So then it can convert into the waste to energy. I mean, it can be the raw material for the waste to energy plants, right? So likewise, the industries, the waste management industries develop in such a way, if the material is having high calorific portion, or the biodegradable waste that convert with this biomembrane technologies, bio-drying technologies into the high calorific value material, then obviously you can get the use those as the energy sources for energy generation, even the electricity generation through the waste to energy. So then I will move on to the landfilling, right? Landfilling, actually, Sri Lanka is only having the functioning landfill is a small landfill at Dompe. That actually the very small landfilling, and unfortunately we couldn't establish this Arwakalu, the large scale landfill so far. But however, in the landfilling technique also, there are certain portions you get the landfill gases. Actually, there are plants in the world that landfill gas converting, supporting for the electricity generation into that level also, right? So even during the landfill technology of waste management, the portion of it can be converted into the electricity generation, right? This is one of such example, landfill gas convert into the electricity. So this is one of the very interesting example which I have found. So there are technologies developed in to generate biogas with your toilet waste, right? So in this setup, you have the waste inlet, and then in the picture you can see digestion process would happen, and then you get the biogas, and this gas would support to get the gas holder, and then that gas would again support for the energy generation point of view, right? So these type of techniques are available. The developed countries actually are using these. And again, these are a kind of biogas plant. And if I talk to you, I mean, about the how the biogas plant works, we all know the organic waste is mixed with, I mean, in order to have the efficiency of the biogas, we always can mix with manure, and then it gives the good output. And it goes into these kind of, the fermentation process, and then it develops gas, and it goes into the different types of energy usages, right? It can be heating purposes, it can connect to grid, it can connect to, the other energy required applications as well, right? So there are a lot of, usages of this biogas production as well. And these are a couple of, not in our country, but the couple of examples. Actually, you can use biogas liquefaction and transport applications, which you can use this biogas for the transport applications, right? All produced through the waste material. And this is another area, especially for the agricultural waste. Now, actually, nowadays, some of these agricultural waste material has become the commodities as well. But as a whole, we can say, still there are in the rural areas, lot of this kind of agricultural waste, right? Rice husk, paddy husk, etc. So actually in this biochar process, you can, pack the energy in this material, and even nowadays, these are exporting to the foreign countries as well, biochar product. And then the energy required, energy, it can consider as the energy source, right? Out of biochar, right? In this picture, you can see, again, biochar can be converted into the biochar, the product, the solid fuel, as well as gaseous fuel, as well as the oil, the liquid phase, right? In this particular biochar reaction, you can convert these material which are having high calorific value sources into the energy sources. And then this is actually, we discuss about the several energy extraction or the energy conversion approaches from the waste material. But not only the energy conversions, energy efficiency also we need to consider, right? So there are, we need to look at the energy efficient techniques as well, right? So, and the renewable energies, right? So, and the fuel switching options. I'm just at this slide because we need to think of, due to all these climate change situations and all the activities that we are doing, we need to consider energy saving aspect as well. And so on one side, Here you can see the picture of Karadiana waste dump yard, the real picture. Still, in the global circularity gap report, in the sense annually they are producing this report, how much of material globally we are convert into the recycling channels out of waste, right? It was target to, like have the 17% circularity in this material by 2032, but up to now it's only 6.9%. This is the global statistic. But however, in Sri Lanka, it's far below than that, right? So still we have these dump yards, and these materials are coming back to the environment without having proper circulation. So there are ways and means to get back this material into the valuable sources, especially the material recovery as well as energy recovery. Oil production, there are options of oil production. As I said, in this material, there are rubber material as well as hard plastic. It's a mix of material composition, and convert those into the refuse derived fuel as we discuss through the waste to energy or even co-processing, etc. And co-fueling and pyrolysis, and even turn these material into the recycling channels. There are huge amount of opportunities are available if you consider this into the business model development. So that is why these type of modeling are happening at the moment in the research level, but that actually can be converted into the practical aspects as well. So with that, what would be our prime responsibility into the future generation? Meet the needs of the present without compromising the future generation to meet the needs of them. That would be our prime responsibility. If we consider this waste to energy conversion approaches, we actually are supporting for the future generation, where you will save the virgin raw material as well as the virgin energy sources. Thereby, you are converting back these waste material into the valuable economic sources while generating the energy of it. Thank you. Now, I think, Nimesha, it's the time for them to raise the questions and any clarifications, etc.
Yes, thank you, Dr. Arosha. It was a very insightful and important presentation. So I'm sure the audience too will have questions to pose at you, as you rightly suggested. And our Joint Secretary, Professor Migara Liyanage, will moderate the session. Professor Migara, the floor is open to you, sir, and you could conduct the session. Thank you.
Thank you, Nimashi, and thank you very much, Dr. Arosha, for that interesting presentation. I think a lot of things we could learn about the waste management and where we are in terms of the country's waste management process. So with this, I would like to request the audience to present their questions. Either you can type or you can raise your hand, or else you can unmute and you can ask your question. I think until someone else comes up with a question, I have a question now. You showed some sort of few locations in and around Colombo. There is solid landfills and so on. Now, how about the waste management process in other cities? I'm sure that several other cities that are populated might be having the same problem. Do they have plans in having some sort of a coming up with some waste management system? Or
Yeah, you mean in our country, right?
Yeah, that's right, in Sri
Yes.
Lanka.
Throughout the country, there are 361, I guess, that number of waste dump yards, right? Most of the local authorities, they have at least one dump site, right? Of which there are suburbs like Highlands, the districts like Kandy, Galle, and towards the Anuradhapura, certain areas of Anuradhapura, And so those are the other cities that are having high amount of waste generation because of the density of the
Population.
the per capita, yes,
Yeah.
population, right? Those also are very pathetic. I mean, in the sense they also don't have that proper waste management. But I would say the most of these local authorities, they are having their own composting operation. Composting operation is available, but then again, the process, because the output of the compost material are not that much, the going out from the plants. There are some quality issues and some the supply chain issues likewise, right? For the biodegradable waste, actually, they have some mechanisms to composting. But I don't know why they are not going on to the bioreaction, I mean the biogas production, etc. Right? There are also certain, the technological issues as well. But all in all, almost all the districts are having the similar kind of waste dump yards. But actually, I would say at least we have Colombo waste to energy plant that has been served for the entire Colombo, majority of the waste. But it's a very good initiative. But still, they are having an issue for the proper disposal of the bottom ash.
There's another question posted by Mr. Nimal Pereira, one of our past presidents. With our knowledge and understanding, what is the best sustainable process you recommend for Sri Lanka waste context, considering the Sri Lankan waste quality and content?
Yes, actually, very good question, Mr. Nimal. So, as per my understanding, initially Sri Lankan waste also need to segregate, right? Unlike the European countries, we cannot mix this biodegradable and non-degradable waste and have the massive, the bio drying and the all these kind of techniques, because it will take very high cost. And actually, we don't have that massive material generation in particular area. Colombo, of course, for this waste to energy plant capacity, we do have, but in the other parts of the country, we don't have that type of massive generation. So we obviously need to go for the segregation. So biodegradable waste as well as the non-degradable waste. So then for the biodegradable waste, composting or even small biogas options would work. But when it's come to the non-biodegradable waste, actually you can go for the RDF, the pre-processing, and then either send those into the waste to energy options. Uh, if at all you can segregate further non-biodegradable waste, if the material can be recyclable, that also would be a useful solution. Actually, that is happening in this yard, waste yard as well, because all these waste pickers, they used to do this. They convert this material into the recycling channels, but then the portion of the unmanaged material would be reduced. Then you can actually that convert into the refuse derived fuel. That is support in our country because of the generation, the number of the waste generation volumes, right? I hope I understood, I mean, answered the Mr. Nimal's question.
Yeah. And Dr. Amila Wickramasinghe, our president, is asking a question. Maldives is planning on starting a 25 megawatt waste to energy power plant. Do you think that it's practical given the scale of waste needed? This question is about Maldives.
Yeah, I know.
Starting a 25
Yes,
megawatt plant.
actually I have experience in Maldives. Once they come to Sri Lanka and ask whether their waste can be disposed by us also when I was work at my previous workplace. But at that time, due to the government regulations, government is not allowing to bring down the waste material to here. So that was not worked out. But I know that Maldives, the waste composition would be, because it's mainly on the hotel sector, the mainly onto the hotel sector, the food waste and the plastic and the what do you call, the refuse derived fuel, RDF portion would be high. there would be but I don't know, 25 megawatt, whether they will get, I mean, then they might have to collect all the waste in all the islands. But at the moment, I know that they are dumping those waste into the one particular area, one island. That is how they manage their waste at the moment. But if the generation of the waste would enough for this 25 megawatt waste to energy plant, that would be a sort of possible option. Practical. Yes,
Yeah.
I'm still having, I mean, even our Colombo 10 megawatt waste plant, we are giving, I mean, it's a total capacity somewhere around 500 to 700 metric tons of waste per day. In that sense, probably this would work because it's like 25 megawatts now. So it's all depend on the waste generation and the waste quality.
Yeah.
I don't have the understanding of their composition, how their waste composition. It's all depend on if the waste is having high calorific value, yes, and the volume generation, yes, this would work.
Next question is about the waste to energy plant in Colombo. And the question is whether it receives enough waste to generate energy.
Last time when I visited there somewhere around last year, right? What they told was at the moment they are getting the waste and they have this problem of disposing the bottom ash. Heaps and heaps of bottom ash are there in their plant. The beside of this plant, actually, they have an issue. Other than that, what they told was they are getting, but they are having another problem where it's, as per their contract, what they told was it's a mixed waste, right? Then the moisture content would also be high. So then their efficiency might get reduced. But at the moment, what they told was because they are getting the waste from the Karadiana as well. Because the sorted waste from the meaning southern part of the Colombo also, they are getting the waste material, the sorted waste material. Yes, optimally in the sense, I don't think they are operating in the optimal solution because it's a mixed waste. There can be high moisture waste and it's not the sorted material. They are not considering the high calorific value also. So what they told was they are managing, but they are getting the material, but there will be the opportunity to optimize that operation, obviously.
Next question is, according to the waste management hierarchy, avoidance is the first step. However, in the case of plastic and so on, it is very unlikely that we duly consider that step in Sri Lanka. Is it the case in other countries as well? And if so, why we still put it as the first step?
It's not that we put in first step. It's the norm, right? It's not that we put that as the first step, right? It's the recognized first step, avoidance, right? So in in Sri Lanka and most of the countries, there are certain countries actually fully, the managing their waste. And I would say most of the European countries, this plastic and these footprints are very high, developed countries. So still now this sustainable consumption and production, all these, the things are popularizing among the communities. So that is where we need to go. And plus, we know that material scarcity, the virgin material scarcity is coming around in the future. Nowadays we are getting this fuel sources, the scarcity in the fuel sources as well, right? So then, of course, the material scarcity also coming in, meaning the virgin materials, then obviously people has to develop their cultures to adhere to this waste management hierarchy. Unless otherwise, you will need, the resources. But of course, there are good technological advantages like nanotechnology, etc. are happening. Technology will develop, but still, this avoidance step should be placed as first and the top. topmost in the waste management hierarchy.
So next question is somewhat related to the first question that I asked. Is there any municipal solid waste facility which carries out waste to energy plant operated in an urban council? Is it economically feasible to have waste to energy plants in urban councils in Sri Lanka?
Yeah, there are. The economics of scale is not there because the urban councils in Sri Lanka, the waste generation is not even 100 metric tons per day, right? There are very few, one or two urban councils, apart from the Colombo area, the other areas, the daily generation is below 100 metric tons per day. Right, so it's actually not economical. I mean, when I was in my previous working place, we actually had the feasibility studies to think of whether it's economical to have another plant like municipals, the waste to energy plants. But then again, the results come out was the waste generation is not enough in our country. Apart from the Colombo area, the other parts of the area, the generation is not enough. Then what happened? The initial cost, the recovery of that cost would go into more than 20 years. But then again, none of the developers and the investors would like, unless government do and have a very, supporting into the infrastructure. Unless otherwise, it's not economical to have a kind of waste to energy plant at the urban council area. However, we tried actually whether the waste of the clustering the urban councils and actually get the more than 100 metric tons out. The one urban council is not willing to take the responsibility of the waste of other urban council. So likewise, some management issues came into picture and practically it was not feasible, right? So that problem was there. I think now also is I had that experience 7 to 8 years back, but still the situation is the same. Then there was a plan. Yes.
Next question is, there was a plan to build up a bioreactor in Kandy with the Peradeniya University. Any idea what happened to it? This is regarding a bioreactor plant which was planned to build in Kandy.
I actually not have proper information on that. But I know that Guhagoda site in Kandy, they were trying to have some biogas or bioenergy something, but sometime back, somewhere around 2012, 2015. But I still don't know the recent update actually.
Next question is, I have recently visited the Aruakkalu sanitary landfill and experienced the facilities there. Still, it's unoperated, and seeing such a facility in that condition is quite unfortunate. When country has such a projects, at some point, implementation and operating it will be very challenging. I would like to have your opinion on this.
Firstly, this concept, this is my personal opinion. This concept was bring to send the waste material generation, the residual material generation at Colombo to Aruakkalu, right? So I had a principal issue there. Then what happened is the operational cost, the transportation. Obviously, you will get some sort of solution for the Colombo waste, but still the cost of this operation would be very high. I mean, I once during my previous company, we did a trial or something to identify how much of cost that it would take from Colombo to bring the waste from Colombo to Aruakkalu. It was like at that time more than 1 lakh per trip, something like that, right? But however, if they can compress and maximally pack this material, that cost would be reduced to certain extent. But that personally, I have that problem, because then how about the carbon footprint, the energy that is going with the transportation to have this? So then this location problem I had. But however, they had initial plan, I would say the sorted material, only the residue would pack and then go into the in the railway line or something, go to there. Only the very small portion of the waste material dump at the Aruwakkalu, the landfilling site, right? So if that happens, that would be some sort of solution. But unfortunately, I don't know what actually has happened, whether that design was fail or something, I don't know. But it's a like of chain of projects. I mean, you should have the Kerawalapiti or somewhere, that the transfer station, all these waste material in Colombo, bring the come into that, and then you will sort that, and the sorted the material only would go into the Aruwakkalu site. So then obviously the transportation requirement would be very minimum because of the less amount of the material that would go into there. But however, still the operational cost would be very high.
Yeah.
Right? So those are the issues I
Yeah.
would say in this solution.
I think
I don't know whether I have answered.
Yeah, I think we are running out of time. We have roughly 2 minutes more, so I will ask two more questions, but very short answers, please. We have a 10 megawatt waste to electricity plant in Colombo. In your opinion, do you think we still have more waste to run another plant? If so, what would be the maximum capacity Sri Lanka can reach in terms of megawatts?
Yeah, as per my understanding, based on the collection volume, the second largest dump site is the Karadhiana. So still there are some amount of waste still dumping. So I would say maximum one more plant with the maximum collection rate. Still, you know, the fully the generation at household level are not fully collected. The city areas actually, yes, but not the peripheral areas properly collecting, 100% collecting. If we collect in 100% for the Western province, actually waste material wise, there would be enough. I don't have the 100%, you know, the statistics with me, the waste volumes, but those days they plan couple of another two waste to energy plants, I would say. But then again, they said that the material generation is not enough for another couple of plants. But at least one more plant, there would be enough waste. But I'm not too sure about the recent statistics.
So I think the last two questions, I didn't see the, anyway, we need to, we have reached the time, but I will, there
Yes.
are two more questions. So brief answers, please. In the Sri Lankan context, what are the key practical barriers, such as technological, financial, or policy related, that currently limit the large scale adoption of waste to energy projects? And how we really could realistically overcome them in the short to medium term? And wouldn't it be feasible to have several smaller scale plants scattered around so that waste collection and delivery to the plant will be efficient? So I know it needs a long answer, but
In
please.
short, I would say you have to have a proper feasibility, because I mean, unless otherwise you can't give the clear answer. But I know the current waste to energy plant still managing with the government promised tariff, but I don't know that the same tariff will give to the another plant as well, right? Because they are struggling. I mean, if they don't get that tariff, they are struggling at the moment, I would say. But if the same scenario happen, I would say there would be some opportunity to another waste to energy option. But however, in order to develop a waste to energy plant, minimum capacity you need to have. Minimum capacity in the sense, minimum amount of waste that you need to have. That would be a issue, right? So in short, I can say like that.
Last question is the externality issue is a common term used by many professionals. Why is this aspect not considered in financial analysis in waste energy plants? Is it calculated in coal power plants? So the question is about
I'm sorry, I'm not
considering
actually.
externality costs.
So meaning what actually he or she is meaning on the externality.
Mr.
Can I
Gomesta, you
talk?
can, yeah.
No, by external, what do you mean means if you not properly manage this waste, it is an environmental damage. So that is a kind of a cost to the society. The power plant energy is a kind of a second element. The first element is the primary objective is to reduce this or the eliminate of this waste. The energy is only a byproduct. But if you put the byproduct as a first product, then all the financial analysis go haywire.
Yeah, I mean, it's actually, it should be the way as an environmentalist, actually, you have to cost the environmental impact in your payback calculation. But I don't know why still the financial perspective, they are not quantifying that portion. I mean, I'm also on to your perspective, but still, I would say the investors, I don't know why it's not coming in the financial calculation, but I hope with the upcoming pressure on the material scarcity and the environmental impact, that portion would come into the environmental projects as well. Right? On the other hand, nowadays it's developed, I mean, the certain financial mechanism to support these environmental projects as well. But so far in the payback calculations, I haven't seen they are not really quantifying the environmental, the cost.
So
Thank
I
you,
think
Doctor.
with this, we would like to wrap up today's session. And thank you very much, Dr. Arosha, for your very interesting session. And I think we had a very productive Q&A session as well. So thank you very much. I think this is one area that we really need to look at, not only in Colombo, but in other places around Sri Lanka as well. I know waste has become a very serious issue. So definitely today's lecture will really be an eye-opener. Thank you very much. And over to you, Nimashi.
Yes, thank you once again, Dr. Arosha, for fielding our questions well. And Professor Migara, yes, thank you very much for moderating the session. And I would also like to make this an opportunity to thank the audience for your enthusiastic participation. And we hope to see you at another enlightening EMF in future soon. Until then, good night and have a pleasant evening. Thank you.
Good night, please. Good night.
Thank you.
Good night. Good night.
Thank you.
Thanks. Thank you.
Right.